Hello students, today we are going to discuss about the IC engine parameters. So these parameters will help us to solve the problems. So we have different parameters are there. Say for example, mean effective pressure, indicated power, brake power, thermal efficiency, brake thermal efficiency. Likewise, so many parameters are there. We need to understand all these parameters, and formulas are there. All these formulas, expressions we have to understand, and after that we are going to solve some problems on IC engine. Okay students, first we'll see about the IC engine parameter. The first parameter is the mean effective pressure. It is designated by MEP and the symbol is PM. So mean effective pressure means what? Mean effective pressure, it is defined as the mean or average pressure acting on the piston throughout the power stroke. So you know very well that in power stroke only we are getting the power. In other stroke, suction stroke, compression stroke, we are not getting the power. So during the power stroke only we are getting the power. So it is a mean effective pressure. It is defined as the mean or average pressure acting on the piston throughout the power stroke. It is also defined as the average pressure developed inside the engine cylinder. So it is expressed in bar. 1 bar is equal to 10 to the power of 5 Newton per meter square. That already you know it. So the mean effective pressure of an engine is obtained from an indicator diagram. So indicator diagram is there. So that is beyond the purview of the syllabus and also for your level. So directly you will understand the indicated power, indicated diagram. It is the PV diagram, pressure and volume diagram, PV diagram. Indicator diagram is a PV diagram for one cycle at that load drawn with the help of an indicator fitted on the engine. So the indicated mean effective pressure is then calculated using the equation. So this is the equation. So PM is equal to spring value of the spring used in the indicator. S, it is designated as S. It is bar per meter multiplied by net area of the indicator diagram in meter square divided by the length of the indicator diagram, that is small l, in mm. So S into A by L, that is in the bar. So mean effective pressure, so PM, mean effective pressure PM is equal to S into A by L. So S is the spring value of the spring used in the indicator, that is designated as, multiplied by A. A is the net area of the indicator diagram divided by the L. All these values will be given in the problem. Simply you need to substitute all the values and find out the mean effective pressure PM. That is the unit for PM, that is the mean effective pressure, is bar. Next we go for next parameter, that is indicated power IP. So indicated power IP, what is the meaning of indicated power? So indicated power, it is defined as the total power developed inside the engine cylinder due to the combustion of fuel. So when you are going to get the power, when the combustion takes place, fuel plus air mixture, combustion, upon combustion of fuel and air, you are going to get a energy. Because of combustion you are going to get energy. So it is power developed inside the engine cylinder due to the combustion of fuel. It is commonly denoted by IP, indicated power. It is expressed in kilowatts. Okay, IP is equal to N into PM, LAN K into 10 by 6. So where N is equal to number of cylinder, L is equal to length of the stroke in meter, N is equal to engine speed in RPM, K is equal to 1 by 2 for 4-stroke engine. So K is a factor. So K is a factor used for easy simplification. So K is equal to 1 for 2-stroke engine and K is equal to half 1 by 2 for 4-stroke engine. And you know PM is equal to mean effective pressure in bar. A is equal to cross sectional area of the cylinder, that is in meter square. So area always it will be in meter square. So indicated power is the power. It is 2 marks question. What is indicated power? What is the brake power? So first you will understand what is indicated power. It is a power. It is defined as the total power developed inside the engine cylinder due to the combustion of fuel. Okay. Next we go for brake power. So brake power is BP, brake power. That means when you apply a brake, Okay, when you apply a brake for a vehicle, so that is the power, brake power. So how will you define the brake power? So net power available at the crankshaft of the engine for performing useful work is called as brake power. So net power available at the crankshaft for performing a useful work is called as a brake power. It is denoted by the brake power BP and is in also in kilowatts. It is a power developed inside the engine cylinder is transmitted to the crankshaft through the piston, connecting rod, crank, etc. Hence, fraction of the indicated power, actual power developed is lost due to friction experienced by the moving parts. Thus, the net power available at the crankshaft is the true output of the engine. That means what? So, when you transfer all the energy, some of the energy will be lost because of friction experienced by the moving parts. So always we will have a friction during the motion. So that you have to minus it. You have to minus. The produced energy is one thing, but after that the energy is consumed by itself. That is the machine itself, because of movement of the piston, connecting rod, crankshaft. Because of the movement of this, the produced energy is consumed by the machine itself. So the net power available, okay, that you have to count it. The net power available at the crankshaft is the true output of the engine and is used for doing useful work. The power available at the crankshaft is measured by applying the brake of some kind of to the pulley of the engine, and this therefore is called as a brake power. So we will apply brake some kind of to the pulley, and we are going to find out the brake power. So formula for this is brake power is equal to BP is equal to 2 pi nt divided by 60 into 10,000 kilowatts. So T means torque, N means the speed of the engine, RPM. RPM means revolutions per minute, and T is equal to torque in Newton meter. So torque is measured by using either belt or rope brake dynamometer. Okay, so we have to measure the torque with the help of belt dynamometer or a rope brake dynamometer. So for this, two formulas are there. So first, how to find out the torque using the belt dynamometer. So torque T is equal to T1 minus T2 into R Newton meter. So this is the pulley. This is the pulley. So this R is the radius. R is the radius, and here it is the belt. We have just tied a belt over the drum or a pulley, and so T1 is the tension in the tight side, that is of the belt, and T2 is the tension in the slack side. Slack means loose side. Okay, tight side, and it's the loose side of the belt. So torque is calculated with the help of this formula. If you use belt dynamometer, so T is equal to T1 minus T2 into R. Newton meter is the unit for the torque. R is the radius of the pulley, that is measured in meters. Next, rope brake dynamometer. So rope brake dynamometer, if you just use rope brake dynamometer for the IC engine in order to find out the brake power, at the time the formula is different. So here it is a rope. You can see the rope is there. It is a wheel. It is a and the rope just moves along with this. So we'll see what is this. So T is equal to force into distance. Torque is equal to, formula is force into distance. So T is the effective load and multiplied by the drum radius. Okay. Next, T is equal to W minus S into R Newton meter. T is equal to W minus S into R Newton meter. So what is S? S is a spring balance reading in Newton. W is the suspended weight in Newton. S is spring balance reading in Newton. R is the effective radius measured from the pulley center to the rope. That is, R is equal to, we can find out the formula with the R in this, with the help of this formula. The radius, diameter of the drum plus diameter of the rope divided by the 2, we will get the R. That is the effective radius measured from the pulley center to the rope center. Pulley center to the rope center. Next is the friction power. So frictional power FP is equal to indicated power minus brake power. That is the frictional power. That is also in kilowatts. Next, mechanical efficiency, eta mech is equal to brake power divided by indicated power multiplied by 100. You will get the mechanical efficiency. Next, thermal efficiency, eta thermal is equal to power output divided by heat supplied into 100. Power output okay, divided by heat supplied into 100. You will get the thermal efficiency. So what is the formula for heat supplied? MF heat supplied is equal to MF into CV. CV means calorific value. MF means mass of fuel in kg per seconds. Calorific value of the fuel is in kg per kilojoules per kg. That is the formula for the calorific value. Now we have two types of mechanical thermal efficiency. So here the one is eta thermal, indicated power by MF into CV into 100. Brake thermal efficiency, indicated thermal efficiency. Brake thermal efficiency is equal to brake power. You have to use brake power. For indicated power you have to use, and brake thermal efficiency you have to use brake power divided by MF into CV into 100. So the last parameter is specific fuel consumption. Specific SFC is equal to MF into kg per hour. This is into it is a unit for MF. That is a kg per hour. We have to use kg per hour only. Divided by power developed. That is in kilowatts. The unit for SFC specific fuel consumption. So specific fuel consumption. The specific fuel consumption is term used to describe the fuel efficiency of an engine design. It measures the amount of fuel needed to provide a given power for a given time period. This measurement helps one judge engine of different manufacturers as to which engine will use the least fuel, which is still producing a high amount of power. That is the specific fuel of consumption, specific fuel consumption. The formula is SFC is equal to MF by power developed. So for unit for MF is kg per hour, power developed is kilowatt. So the unit for SFC is kg per kilowatt hour. Okay, so MF is equal to mass of fuel. Indicated specific fuel consumption, brake specific fuel consumption, both are there. So for this formula is fuel consumption in kg per hour divided by indicated power, because we are using indicated power here. That is the indicated power in kilowatt. The unit for this is kg per kilowatt hour. Next, brake specific fuel consumption is, so fuel consumption in kg per hour divided by brake power in kilowatt. So here also same thing, numerator is same, but the denominator is indicated power, because indicated is SSC, and here denominator is brake power, because we are finding out the SFC of brake power. That is why you use brake power that is in kilowatt. So unit for this is same, kg per kilowatt hour. So come on, next we go for the solving some few problems. Okay students, first problem. A 4-stroke diesel engine has a piston diameter 250 mm and a stroke 400 mm. The mean effective pressure is 4 bar and the speed is 500 rpm. 500 rpm. rpm is revolutions per minute. The diameter of the brake drum is 1000 mm and the effective brake load is 400 Newton. Find the indicated power, brake power, then frictional power. So the given data, what is the given data? First one. So given engine, what type of engine it is given? So engine is 4-stroke diesel engine. 4-stroke diesel engine is given. And for 4-stroke diesel engine, what is the K factor? K is equal to 1 by 2. Next, piston diameter you have to calculate. Piston diameter. So piston diameter is equal to cylinder diameter. Both are same. Piston diameter is equal to cylinder diameter. So that is D is given. It is 250 mm. So 250 mm, that is you have to convert into meter, 0.25 meter. So therefore area, area of the cylinder A is equal to, formula is pi by 4 D square. Okay, so pi by 4 multiplied by diameter is 0.25 whole square. You will get the value for area is 0.049 meter square. So this is the area of the cylinder or a piston. Now stroke length, you have to get the value, the stroke length L is given here. Stroke length L is equal to 400 mm. So 400 mm. So again convert this into meter. So 0.4 meter is the stroke length. Next, mean effective pressure, MEP, mean effective pressure, is a PM is equal to, given 4 bar it is given. And speed also is given. Speed, it is designated as n, is 500 rpm. Next, diameter of the brake drum. Diameter of the brake drum, capital D, is equal to 1000 mm. It is given. It is 1 meter. Therefore, radius. So, radius of the brake drum is equal to R is equal to 1 by 2. So, 0.5 meter. Now we have to find out the indicated power first. What is indicated power formula? So we know that indicated power is equal to, so before that we find out the effective brake load. So effective brake load is equal to W minus S. So that is equal to 400. W minus S is equal to 400 Newton. Okay. So that is given, effective brake load is given 400 Newton. Then assume a single cylinder engine. So N is equal to 1. So now indicated power formula is in IP is equal to N into, N means number of cylinder. So into PM, mean effective pressure, L A N K into 10 by 6. So N is 1, mean effective pressure is 4 bar, multiplied by stroke length is 0.4 meter, area of the cylinder is 0.049, multiplied by N RPM is 500 RPM, multiplied by the K value is 1 by 2, then multiplied by 10 by 6. So if you compute in calculator, you are going to get the value of 32.66 kilowatt. So this is the indicated power. Next, brake power. So brake power formula is 2 pi nt by 60 into 1000 kilowatt. This is the formula. So 2 into pi, N is 500 rpm. So torque, you have to find out the torque. So this torque is given, the brake drum. So you have to use the formula torque. So T is equal to W minus S into R. So W minus effective load is given, effective brake load is given 400, multiplied by R is given. I found out the R value, so 0.5. So that is equal to 200 Newton meter. So torque is equal to 200 divided by 60 into 1000. So again, if you compute in the calculator, you are going to get the answer 10.47 kilowatt. So this is the brake power. Next, frictional power is equal to IP minus BP. So IP value is 32.66 minus 10.47. You will get the frictional power is equal to 22.19 kilowatt. So this is the final answer, 22.19 kilowatt.